Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache EventMesh, a powerful, open-source eventing platform designed for the modern cloud. In today's fast-paced digital world, applications need to communicate seamlessly and in real time. EventMesh makes this possible by acting as a central hub for event-driven communication. Whether you're dealing with IoT sensors, microservices, or enterprise systems, EventMesh bridges the gap between different protocols and platforms. Let's begin by understanding why this technology is becoming a game-changer in distributed systems. Before diving into EventMesh, it's crucial to understand event-driven architecture. In this model, system components communicate through events rather than direct calls. This decoupling allows for more flexible, scalable, and resilient systems. Events are produced by one component and consumed by others, enabling asynchronous processing. This approach is particularly powerful in microservices environments where components need to scale independently. EventMesh acts as the nervous system of such architectures, managing event flow efficiently. So why choose Apache EventMesh over other messaging systems? EventMesh stands out for its multi-protocol support. It can handle everything from HTTP and MQTT to Kafka and gRPC. Built from the ground up for cloud-native environments, it integrates seamlessly with Kubernetes and other CNCF projects. Beyond just message passing, it provides event orchestration capabilities, allowing you to build complex workflows. As an Apache project, it benefits from a strong open-source community and enterprise-grade reliability. Let's break down the core concepts. In EventMesh, events are structured data packets that carry information from one system to another. The mesh acts as an intelligent communication layer that routes these events. It uses a publish-subscribe model, where producers publish events and consumers subscribe to topics of interest. One of its most powerful features is protocol translation, allowing systems using different protocols to communicate seamlessly through the mesh. The architecture of Apache EventMesh is elegantly modular. At the edges, you have event producers and consumers, your applications and services. The EventMesh core services manage event routing, filtering, and delivery. Protocol adapters handle translation between different communication protocols. Behind the scenes, a storage and routing layer ensures events are delivered reliably and efficiently. This separation of concerns makes EventMesh both flexible and robust. One of EventMesh's standout features is its extensive protocol support. For web applications, it supports HTTP and WebSocket, making integration straightforward. IoT devices can communicate via MQTT, a lightweight protocol ideal for constrained environments. For high-throughput data streams, it integrates with Apache Kafka. And for modern microservices, gRPC support enables efficient, strongly typed communication. This versatility means you can connect virtually any system to your EventMesh. EventMesh implements a robust publish-subscribe model, which is fundamental to its operation. In this model, producers publish events to specific topics without knowing who will consume them. Consumers subscribe to topics of interest, and the mesh handles distribution. This decoupling allows for incredible scalability. You can have thousands of consumers for a single topic. EventMesh supports various subscription models, including broadcast, queue, and failover, giving you flexibility in how events are processed. EventMesh goes beyond simple message passing with advanced routing and filtering capabilities. Content-based routing allows events to be directed based on their payload, not just their topic. Filtering can happen at the source, reducing network overhead. Subscriptions can be updated dynamically without restarting services. And routing rules can be managed centrally, giving you fine-grained control over event flow in complex systems. This intelligence makes EventMesh more than just a message broker. It's an event router. As a cloud-native platform, EventMesh integrates seamlessly with modern infrastructure. It's designed for Kubernetes deployment, with native support for service discovery and load balancing. Auto-scaling capabilities ensure it can handle varying loads efficiently. Built-in observability features provide metrics, tracing, and logging for monitoring event flows. This cloud-native approach means you can deploy and manage EventMesh with the same tools and practices you use for your other cloud services. EventMesh supports pluggable storage backends, allowing you to choose the right solution for your needs. Whether you need simple in-memory storage for high-speed processing or durable persistence for critical events, EventMesh can accommodate. Event replay capabilities let you reprocess historical events, which is invaluable for debugging and analytics. The system provides configurable durability guarantees, ensuring events aren't lost even in failure scenarios. Performance optimization features ensure storage doesn't become a bottleneck. Security is paramount in any distributed system, and EventMesh doesn't disappoint. It provides robust authentication and authorization mechanisms to control who can produce and consume events. Transport layer security ensures events are encrypted in transit. For sensitive data, payload-level encryption can be applied. Comprehensive audit logging helps track event flows for compliance and troubleshooting. These features make EventMesh suitable for enterprise environments with strict security requirements. EventMesh is engineered for performance and scalability. It can handle millions of events per second, making it suitable for high-volume applications like IoT telemetry or financial trading systems. Horizontal scaling allows you to add more nodes as demand grows. Low-latency delivery ensures real-time responsiveness, critical for time-sensitive applications. Efficient resource utilization means you can run EventMesh cost-effectively, even at scale. These characteristics make it a powerful choice for demanding production environments. Let's walk through a complete EventMesh workflow. First, events are produced and ingested through various protocols. The protocol translation layer normalizes these into a common format. Next, the routing and filtering engine determines where each event should go based on subscriptions and content. Finally, events are delivered to consumers with appropriate delivery guarantees. This workflow is designed for both speed and reliability, handling everything from simple notifications to complex event processing pipelines. Let's look at a compelling real-world use case, a smart city IoT system. In this scenario, thousands of sensors, traffic cameras, air quality monitors, smart meters, produce data using various protocols. EventMesh ingests this heterogeneous data stream, normalizing it for processing. Real-time analytics engines subscribe to relevant topics, processing data for immediate insights. Emergency services might receive alerts for critical situations, while city planners get aggregated data for long-term planning. This showcases EventMesh's ability to handle massive scale and protocol diversity. How does EventMesh compare to other technologies? Compared to Apache Kafka, EventMesh offers broader protocol support beyond just Kafka's native protocol. Against RabbitMQ, it has a stronger cloud-native focus and more modern architecture. Unlike proprietary solutions like AWS SNS, it provides open-source flexibility and vendor independence. And while gRPC excels at service-to-service communication, EventMesh addresses a broader range of eventing use cases with its mesh architecture. Each has its place, but EventMesh uniquely combines versatility with cloud-native design. Ready to get started with EventMesh? The process begins with downloading and installing the platform, which supports various deployment models, including Docker and Kubernetes. Next, you'll configure basic settings like storage backends and network interfaces. A simple producer-consumer example helps verify your setup. EventMesh provides monitoring and debugging tools to track event flows and troubleshoot issues. The community offers extensive documentation and examples to accelerate your learning journey. In microservices architectures, EventMesh serves as the communication backbone. Services no longer need direct API calls, reducing coupling and improving resilience. Event-driven choreography allows complex business processes to emerge from simple event exchanges. Cross-service data consistency is maintained through event sourcing patterns. When services fail, EventMesh's durability features ensure events aren't lost. This approach enables highly scalable, fault-tolerant microservice ecosystems that can evolve independently. EventMesh supports advanced patterns like event sourcing, where application state is derived entirely from an immutable log of events. This approach enables complete audit trails, making it ideal for compliance-sensitive applications. State can be reconstructed at any point in time by replaying events. Combined with Command Query Responsibility Segregation, or CQRS, it allows for highly scalable read and write operations. These features make EventMesh suitable for complex enterprise applications requiring detailed historical tracking. EventMesh excels in hybrid and multi-cloud environments. It can route events between different cloud providers seamlessly. Hybrid deployments allow on-premises systems to communicate with cloud services through the mesh. Edge computing scenarios benefit from EventMesh's lightweight footprint and protocol flexibility. Global event synchronization ensures consistency across geographically distributed systems. This makes EventMesh an ideal choice for enterprises with complex, distributed infrastructures. Observability is built into EventMesh from the ground up. Comprehensive metrics collection tracks throughput, latency, and error rates. Distributed tracing support helps debug complex event flows across multiple services. Event flow visualization tools provide real-time insights into system behavior. Custom alerting mechanisms can notify operators of anomalies or performance issues. This observability stack ensures you can maintain and optimize EventMesh deployments with confidence. EventMesh comes with a rich ecosystem of tools and integrations. Command line interfaces and management tools simplify deployment and operations. SDKs for popular languages like Java, Go, and Python make integration straightforward. Integration with other CNCF projects like Prometheus, Grafana, and OpenTelemetry enhances its capabilities. Both community support and commercial enterprise options are available, giving you flexibility in how you adopt and maintain EventMesh. Let's examine some performance benchmarks that demonstrate EventMesh's capabilities. In typical production scenarios, it handles millions of events per second with consistent sub-millisecond latencies. Resource utilization remains efficient even under heavy load, thanks to its optimized architecture. Linear scalability means adding nodes directly increases throughput. These benchmarks show why EventMesh is suitable for demanding applications like financial trading platforms or large-scale IoT deployments. Compared to traditional messaging systems, EventMesh represents a fundamental shift in approach. While legacy systems often support only a single protocol, EventMesh is inherently multi-protocol. Its cloud-native design contrasts with older deployment models that require complex infrastructure management. Instead of point-to-point connections, EventMesh creates a dynamic event mesh that adapts to your architecture. And rather than static queue configurations, it offers dynamic routing that evolves with your system's needs. EventMesh provides powerful capabilities for enriching and transforming events in flight. Real-time data enrichment allows you to add context or metadata as events pass through the mesh. Schema validation ensures data quality and supports schema evolution over time. Event format transformation can convert between different serialization formats like JSON, Avro, or protocol buffers. Content-based enrichment rules can dynamically modify events based on their payload, enabling sophisticated processing pipelines without changing your applications. Resilience is built into every layer of EventMesh. Automatic failover mechanisms ensure continued operation even when individual nodes fail. Event durability features prevent message loss during system outages. Circuit breaker patterns protect services from cascading failures. Graceful degradation strategies allow the system to continue operating at reduced capacity during issues. These features make EventMesh suitable for mission-critical applications where reliability is paramount. In financial services, EventMesh enables real-time transaction processing with the reliability and compliance features required by the industry. Complete audit trails satisfy regulatory requirements while maintaining performance. High availability configurations ensure continuous operation even during maintenance or failures. For trading systems, its low latency capabilities support high-frequency trading scenarios where microseconds matter. EventMesh's security features also help protect sensitive financial data throughout the event lifecycle. EventMesh prioritizes developer experience with comprehensive SDKs for popular programming languages, including Java, Go, Python, and more. Detailed API documentation makes integration straightforward. Interactive examples and tutorials help developers get up to speed quickly. IDE integration and tooling support streamline development workflows. This focus on developer experience accelerates adoption and reduces the learning curve for teams implementing event-driven architectures. As systems evolve, event schemas inevitably change. EventMesh integrates with schema registries to manage this complexity. Backward and forward compatibility features ensure smooth transitions when schemas evolve. Automated schema evolution capabilities can handle many common changes without manual intervention. Version-aware event routing directs events to appropriate consumers based on their schema version. This robust schema management prevents the common pitfalls of schema drift in large event-driven systems. EventMesh's lightweight footprint makes it ideal for edge computing scenarios. It can run on resource-constrained devices while maintaining full functionality. Intermittent connectivity is handled gracefully with local buffering and eventual consistency patterns. Edge-to-cloud synchronization ensures data consistency across distributed systems. Optimizations for resource-constrained environments make it suitable for IoT gateways, mobile deployments, and remote installations where traditional messaging systems would be impractical. As an Apache Software Foundation project, EventMesh benefits from proven open-source governance. An active community of contributors drives continuous improvement and innovation. Regular release cycles ensure new features and fixes are delivered consistently. The transparent governance model gives users visibility into project direction and decision-making. This strong foundation provides confidence for enterprise adoption while maintaining the agility and innovation of open-source development. Looking ahead, EventMesh has an exciting roadmap. Integration with AI and machine learning will enable intelligent event processing and automated routing decisions. Enhanced streaming analytics capabilities will provide real-time insights directly within the mesh. Serverless event mesh functions will allow custom processing without managing infrastructure. And as cybersecurity evolves, quantum-resistant security features will protect against future threats. These innovations position EventMesh at the forefront of event-driven architecture evolution. When adopting EventMesh, start with simple use cases to build familiarity with the platform. Plan for schema evolution from the beginning to avoid future migration challenges. Implement comprehensive monitoring to maintain visibility into event flows. And always design for failure scenarios. Event-driven systems can fail in unique ways that traditional architectures don't experience. Following these best practices will ensure a smooth and successful EventMesh adoption journey. EventMesh enables several powerful implementation patterns. Event sourcing architectures use events as the system of record, providing complete audit trails and temporal queries. Command Query Responsibility Segregation, or CQRS, separates read and write operations for optimal performance. The Saga pattern manages distributed transactions through event choreography, and event-driven microservices communicate through events rather than direct API calls. These patterns, enabled by EventMesh, solve common challenges in distributed system design. Effective troubleshooting in EventMesh involves event tracing to track flows through complex systems. Performance monitoring tools help identify bottlenecks in event processing pipelines. Configuration validation ensures settings are correct and optimal, and robust error handling strategies prevent cascading failures. The platform's observability features provide the visibility needed to debug issues quickly, while its resilient design minimizes the occurrence of problems in the first place. EventMesh integrates seamlessly with the modern cloud-native stack. Kubernetes operators simplify deployment and management in containerized environments. Integration with service meshes like Istio provides additional observability and security. Cloud provider services can be easily connected through EventMesh's protocol adaptability. And CI/CD pipeline support enables automated deployment and testing. This integration makes EventMesh a natural fit for contemporary development and operations practices. To summarize, Apache EventMesh represents a significant evolution in event-driven architecture. Its protocol-agnostic approach solves integration challenges between disparate systems. The cloud-native architecture makes it perfect for modern distributed applications. Built-in scalability and resilience features ensure it can handle enterprise workloads. And as an open-source project, it benefits from continuous innovation and community-driven improvements. EventMesh is not just a tool, it's a platform for building the next generation of distributed systems. Thank you for joining this comprehensive exploration of Apache EventMesh. We've covered everything from core concepts to advanced features, real-world use cases, and implementation best practices. If you found this content valuable, please like and subscribe for more deep-dive tutorials on cloud-native technologies. I'd love to hear about your EventMesh use cases in the comments below. For hands-on learning, explore the official documentation and consider joining the vibrant community forums. The future of event-driven architecture is here. Are you ready to embrace it with Apache EventMesh? And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.